Good day, students. We've been given a beautiful trapezium question. Now, the important challenge for this question, as you can see this on the figure, is the base is given in terms of x. I can clearly see the base 1 is x positive 5 and base 2 is 2x negative 4. That's the base. Now, you can also see a blue line. Now, that is called as a midsection. Now, that has a value of 12, and you can see a green line, and that is the height of the trapezium. That is also given in terms of 3x negative 2. Now, the all important question here is, given the midsection and the base also being given along with the height, we are expected to find the value of x. We need to get the value of x, and then we will have to get the basis. Now, I'm going to show you two different ways to write the Python code. Foremost, what I'm going to do is I'm going to write a Python code to handle this part, right? To handle this question. That is, the basis being x positive 5 and 2x negative 4, the midsection being 12, and the height being 3x negative 2. So let's go up and start our process. So this is the PyCharm environment. Let me make some spaces here. Okay, that's fine. So I'm going to give a command. This is the Python code to find the basis and the height of the given trapezium. Right? So the information is given unto us. So let me write down this information. Now the base 1 is given as x positive 5. Base 2 is given as 2x negative 4. The height is equal to 3x negative 2, and the midsection being equal to 12. Now what I'm going to do is I'm going to actually display a few important information. So print, this is the application to find the value of x for this question. So I'm targeting this question. Probably you can say print and given some design, say 30, and then we would have to get the midsection. Okay, so midsection is, for this question, it's 12. So we need to get the formula for x. So what is the formula for x? X value is equal to 2 multiplied with the midsection, and that has to be subtracted with the value of 1. So I'm placing a square parenthesis. No, you can just place a curly parenthesis, and then we need to divide that by 3. Okay, now this is going to produce me the value of x. Now you might be asking me, how did I come across this formula? Now I'm going to place in the link how exactly I've calculated the expression x. So you can please see that that video, and then you can let me know your thoughts. So this expression, as I mentioned to you, I have got this expression from basic calculations, and please check that video also. So x value is got from here. Now once x value is got, what we need to do is we need to print it. Print the value of x is equal to x value, and then we need to find the basis, right? Print the base 1 is equal to, what is the expression for base 1? X positive 5, right? So x value added up with 5, that's the base 1. Now I'm going to print the base 2. What is base 2? Base 2 is 2 times x. So 2 multiplied with x followed by negative 4. That's the base 2. Now ith, print the ith is equal to, the ith is 3 times the value of x, and then you take away 2 from that. So we got the ith. Now we need to find the area of the trapezium. So I'm going to give an empty print, then I'll say print the area of the trapezium is equal to, what is the formula? Half times base 1 plus base 2 times height. So I'm going to write half as 0.5 multiplied with base 1. So we need to get the base 1 value. So this is going to be the base 1 value. Base 1 plus base 2. This is going to be the base 2 value. Right? So probably I'll put in the base 2. I will put in a parenthesis here so that this is base 1 added up with base 2. I will place in a parenthesis base 2, first base, second base, and the final parenthesis, and this has to be divided by h, right? So I divide by ith. This is my ith. So put a parenthesis over here. Okay. Now if you want, you can put in special variables, exclusive variables, and then do that. I don't need the plus sign there. Okay. So this is the expression, and 2 times x value, that's fine, x value, and then okay, probably what I will do, I will take this out. So I will, instead of saying this print statement, I will say numerator 1. It's better to calculate like this. Numerator 1 is obtained, and then denominator this is the denominator, and then what I will do is I will have to perform the area, right? Area calculation is equal to numerator divided by denominator. Okay, and then I will print that down here. Print the area of the trapezium is equal to area, and then I'm going to place in units, square units. That's it. So I will execute it, and then probably I can also give the value of the midsection here. Print the midsection given, this is given, equal to and then you give midsection value just to be complete. Okay, so let's check for errors or anything for that matter. Midsection is this, and let me check the value of x. 7.6 absolutely correct. The base one, let me check the base one value, absolutely correct. Base 2 absolutely correct. Height absolutely correct. And the area of the trapezium for this is 0. So base 1, base 2, let me use my calculator and make the check. So calculator, base 1 plus base 2. Base 1 is 12 plus this multiplied with height, and this has to be divided by 2. Okay, so half times base 1 into base 2. So there is a problem here. Okay, I got the point. The problem is the calculation. It should not be numerator divided by denominator. It should be, it's actually the height value, right? So half into height should be in the numerator. Half times base 1 plus base 2 times height. So I'm going to change this variable, numerator 1, numerator 2. Both of them are present in the numerator, right? Because this 2 is already brought to the numerator as 0.5. So this should be different. So times numerator. Okay, so that's fine. Let me run it and check it out. Okay, let me check with the calculator. 241.5. That's because I have not taken in the decimals. So if I were to take in the decimals, you can clearly see that value 252 would come in place. So let me just show you that. 12.66 plus 11.33, base 1 plus base 2, multiplied with height 21, and then this has to be multiplied with 0.5 because we have to divide it by 2, but instead of that I'm taking it as 0.5. You see that? 251.895. So that is a lovely output, and we have demonstrated that using the Python code. So that is the solution for this question. Of course, in the next class we can give a generalized case in the Python code. Thank you, students. Enjoy your day.